মানুষ বাঁচেনি আগে মেশিন লার্নিং করতো না আমার চোখের কি আছে
আরে স্যার
Okay, so welcome back everyone.
it is sir.
Is this visible to everyone? The pin diagram?
Yes sir. Yes sir.
Okay, so shall I start?
Yes sir.
Okay, now these 8 pins, those are hold HLDA, WR bar, M/IO bar, DTR bar, then DN bar, ALE and INTA bar. These 8 pins are available in minimum mode only. Okay, minimum mode only, and the functions are in this way. This hold and HLDA, these 2 pins are available for DMA purpose, direct memory access. Direct memory access. All of you have heard about this DMA.
Yes sir.
8085 also. So okay, so this DMA process means direct memory access, where you need to give a certain request signal and then one acknowledgement signal is to be processed. So hold is the request signal and HLDA, that is the acknowledgement signal that is coming from the 8086 microprocessor. So these 2 pins are available for DMA purpose. Next is the write signal. So write signal, that is used in for write operation. M/IO bar, this is for memory or IO related operation, to identify whether it is memory related operation is going on or IO related operation is going on. To identify this operation, either this pin may be 1 or 0. In 8085 it was just opposite to this one, like it was IO/M bar in 8085, but in 8086 it is IO bar/M or M/IO bar, just opposite to this one. Don't confuse with the 8085. Okay. Next pin is for DT/R bar, data transmit or receive purpose. Now if any data is to be transmitted through the data bus or it is received by the processor through the data bus, then this signal is used. If it is 1, if this pin is 1 or this signal is 1, then data is transmitted through the data bus, and if this pin is 0, it represents it is used for receiving purpose. Okay. And DEN bar means data enable, whether is there any data available in data bus. If there is any data to access the data through the data bus for external circuitry purpose as well as for internal. So for external purpose it is used, or internal purpose it is used to represent there is a certain amount of data available in data bus buffer. You have to transfer or receive the data according to your requirement. So it is identifying the data are available in data bus buffers. So data enable signal, if this pin is low, then it represents the data is enable or available. ALE signal means the address latch enable. The same thing, the same signal is used to multiplex this address and data bus from AD0 to AD15. ALE, address latch enable. INTA bar, the same thing, interrupt acknowledge, means if any signal is coming through this INTR pin, INTR, interrupt request pin, then this is the acknowledgement signal which is to be given by the processor to that corresponding device, requesting device. So these are the signals in minimum mode, or pins are used in minimum mode. The same pin that is used for different purpose in maximum mode, like these two pins are RQ bar and GT0 bar, and RQ bar or slash, it is GT1 bar. So these pins are for request and grant the operation or the bus access. So if in case of DML process, it is used to represent, or it is used to grant the permission or request the permission, or request to give some signal. So request and grant, these two pins are available. Lock bar pin, that is used to lock the other masters for not to get any control over the buses. Because if there are two processors, so at a time one processor is involved to perform certain operation, at that time you have to lock the other processor or other master, so that it is not to gain any control over the system buses. That's why this lock bar pin is available, and this lock bar pin or signal can be affected or can be accessed through the lock instruction. You have to write the instruction so that it will function according to your requirement. Okay, so there is an instruction called lock prefix instruction in 8086. You have to use this. Using this instruction, you have to lock the system or lock the other bus masters to not gain the control of the system buses, over the system buses. So next, three pins are available for S2, S1 and S0. These are status signals to represent certain operations, like can you remember three signals? Those are present in 8085, like IO/M bar, S1 and S0. Like if these three combinations, these three signals combinations are 0, 0, 0, then it is in halt state. If this is 0, 0, 1, it is memory write. Then if it is 0, 1, 0, it is memory read. If it is 0, 1, 1, the opcode fetch. Okay, so these type of combinations are available here also using these three signals, S2, S1 and S0. Interrupt acknowledge, memory read, memory write, halt state, no operation. So every operation status can be identified by the combinations of these three signals. Okay, there is a table, you have to remember this table. Then next two signals are for QS0 and QS1. I think here the tables are present. These three signals can be represented in this way. If these three status signals are 0, 0, 0, then it is interrupt acknowledge. Then 0, 0, 1, it is IO read. Next is IO write, halt, instruction fetch. Then memory read, memory write, or inactive state, or no operation will be performed in this case. The next is the Q status 1 and Q status 0. So actually this status represents the previous cycle, what was going on in that cycle. If these two pins are 0, 0, then it represents no operation, nothing is taken from the queue. If this one is 0, 1, that means the first byte is available, from the queue to execute. Then 1, 0, it has nothing, queue is empty, so no operation is there. And if these two pins are 1, 1, then it represents the first is the first was the opcode, then the subsequent byte, it is transferred from the queue to the execution site. Okay, so that is the subsequent bytes are transferred from the queue to the execution unit for execution purpose. So these are the status signals representation. So now this is the minimum mode configuration, how the mode will be configured, and this is the maximum mode configuration, how the mode will be accessed or interfaced. So I will discuss these two things on next day or next lecture, how this everything means 8086 or latch or the trans receivers or bus controller can be accessed or can be interfaced to perform the maximum mode operation configuration and the minimum mode configuration. Okay, this one. So these two diagram I will be explain on next class. Okay, so clear up to this much? Is this clear? The pin configuration for maximum mode. Is there any confusion or doubt?
So what is the test bar? 23 pin number.
Test bar pin. Test bar pin, it is used to check the wait state configuration, whether microprocessor goes into ideal state, means wait state, or not. It is the currently performing such operation. Okay, if test bar pin is low, if this pin is low, that means normal operation is performed, no problem. But if this pin is high, that means it goes into ideal state. Okay, no operation is performed or in wait state. Another thing, and another question.
Can you repeat the RQGT part?
RQGT bar, these two pins are available for DMA purpose. DMA purpose. So one master, there are two processor. One has to give permission to another if any signal is coming from the external side to perform the DMA operation. So that's why request and grant operation is there. So always the request at GT0, it has the highest priority compared to RQ GT1 bar. So at a time, if the two signals are coming through these two pins, okay, only one which is to be connected to the one master, first master or first microprocessor, that is to be used to perform the DMA operation. Okay, GT0.
And the operation is same as that hold part.
Yes, yes. It's because there was only single processor, so there is nothing for grant access or the request signal. Only hold and HLD is. But in this case, maximum mode operation, more than one processor is involved. So any one processor can access the or can give the permission to the 8237 DMA controller or 8257 DMA controller to access the data bus or every buses, system buses to perform the DMA operation. So that's why this RQ GT0 and GT1 is to be connected with the multiprocessor. Another question? Anyone else? From the previous day till now, do you have any queries from the previous day lecture until now? Do you have any queries?
Sir, there was a doubt that when in pipelining architecture, when the execute and fetch is going on, sometimes it stops. And
I can't understand your question. Please make it clear.
sir, in that execution and fetch operation, the pipelining architecture,
Yes.
sometimes the execution and fetch is stopped. Why it is occurring like that? Means it is fetching and the execution at the time.
Execution is not stopped in any way. Execution is performed. Okay, because until the queue has been empty, the upper 2 byte space, execution is continue going on. So when the queue has been filled up by such fetching operation until the upper 2 byte is empty, no fetching is to be performed. But your execution is continue going on. Execution is not stopped.
The fetch gets stopped, but not the execution.
Yes, fetching can be stopped, but execution stop means in that way it is always decreasing its space. It is not in position that it is stop the decreasing its space. So when the upper 2 byte is empty, the fetch is going on. Okay, so in this way, when upper 2 byte is there, lower queue position is empty because it is going to execute, ready for execution. At that time, upper 1 byte, upper bit, 8 bit is empty at that time. Okay, at that time, so no fetching operation will be performed until the next bit is replaced by the or empty the current position. So fetching at the means, so one meaning is to be stop fetching, but actually the whole process is going on continuously.
Hello,
Yes.
sir. So in the memory banking part, you said that if we had to access the odd part, the A0 should be 1.
No,
And you also said that the
sorry,
BEG.
no. If you want to access the even bank, then you have to select A0. If you want to select odd bank, you have to select. So even, that is the lower bank, even bank, that is the lower bank, which will be enabled by the A0 line. Okay, and the upper bank, which is called the odd bank, that can be enabled by BHE bar.
All right. Okay.
Next, anyone else? So is there any queries? So if you have no queries or no doubts, so I will end this meeting, and that is the that's all for today. I will discuss the axiom mode configuration on next day. Okay. So thank you all.
Thank you, sir.
Thank you, sir.
Okay. I will end this meeting. Thank you.